Hi, just a little interesting thing I just noticed. I hadn't really paid much attention to it, or I would have noticed it sooner. The clues were all there. But if you look at this page here, iss.astroviewer.net, and watch the map, it's a bit like watching grass grow, I guess you might say. Um, do you see the map moving? I mean, it's an interesting thing because I kind of knew it was moving all along, but really hadn't actually noticed it moving. Hadn't really stopped to think about it. And as a matter of fact, the little X down here near the bottom, or not X, but a little plus sign, that shows where the International Space Station is right now, and that is in real time. Now, I had actually thought, without really bothering to look or pay careful attention, that the plus sign was moving across the screen and the map was staying still. Once in a while, I would refresh it. I would refresh the page uh, to set the plus sign back at the beginning of this little red line, and thereby gain a little bit more on the other end here to show where the path is going further. But I hadn't really looked to see, was it the plus sign that was moving, or was it the map that's moving? But you might notice, depending whether or not you looked at where that plus sign was when I started filming this video, that the vertical line in the little plus symbol, or in the crosshairs, was on the left side of New Zealand on this map. Now it's not. Now it's just to the right of New Zealand on this map. And as I continue to talk, as time continues to go by, New Zealand is getting farther away from it. If you look at the word Europe over here, the label Europe over here on the upper left, you can see it's very close to the edge. And it doesn't look at a glance like it's moving, but it is. If you give it more than a glance, this is the same thing as when you look up into the night sky and it looks like the stars are staying in one place at a glance. But if you watch them for a while, it doesn't take very long to see that they actually are moving. If you've got some point of reference that's staying still, not like a wildly waving tree branch or something, but maybe the corner of a building, or maybe a far away tree, uh, or if the wind isn't blowing the branch around, maybe even a nearby one, or a V in a branch of a tree where you can see through to a particular star. If you line up some star with some thing that isn't moving with relation to you, or especially if you can manage to line it up with two different things at two different distances away from you, so that they're both lined up with a particular star, it takes probably just a few seconds to be able to easily tell that it has moved. I've been using the same method, heck, pretty close to all of my life, I would say, since early childhood, to be able to tell what direction clouds are moving. I actually had read a book about meteorology while I was still in the crib, before I was old enough to talk, and it gave me an interest in that. So this is where I came up with the interest in knowing which way the clouds are moving. Um, I'm not sure exactly at what point in time I realized how to tell, but it could be that this is why I so clearly see that the Earth is not flat as flat earthers claim it is, because it wouldn't work. If you observe the things around you, you can see none of their models work. Now, sure, some of the land is relatively flat compared to, say, for example, a beach ball, which is, pretty round, or a mountain, which Earth does have. But it depends on the scale you're looking at, and it depends on the particular land you're looking at. If you look at the ocean, like right now, you might notice the International Space Station, according to this map, is over the ocean. Um, in the daylight, by the way. So if I switch over to here, um, if the signal's working, oh wait, there. Give it a moment to load. That should actually uh, show the International Space Station over the ocean, and there it is. And you can see clouds below it and the horizon. Notice the straight line from here to here. Notice the straight line from here to here. Those lines are quite straight um, compared to this line from here to here. Now, that's not a huge curve. And if you look at just that section of the curve, if you look at just that section of the curve only, and not at this section over here, and this other section over here, and this other section over here, it might be a little difficult to tell for sure. Is that really curved, or is it just sort of an optical illusion? But yeah, that's definitely curved. And when you look at these videos people make, it's a rare thing, but occasionally some flat earther will actually do something like sending a balloon up into the air. And this is cool that they're actually willing to do that, because they're testing. But then they use confirmation bias, and generally they use camera lenses that skew and distort the image. And yeah, if you understand those distortions, you can know how to work around them in the image. In this case, though, these straight lines should indicate to you very clearly that this camera is not distorting the image. That curvature is real. And well, it may look like we're in New Zealand, because we're the International Space Station is actually near New Zealand, and the Earth is up on this picture. That's sort of a coincidence, because if we were on the northern hemisphere, it would still look that same way, because it's the position the camera's in and the position the International Space Station is in that is leaving the Earth look like it's above us in this case, or above the space station. It's all relative. I mean, the space station has so little gravity that from the perspective of inside the space station, there really isn't any up or down. Not any clear up or down anyway. So generally I would think they would consider to be toward the Earth to be down. And the thing is, they're falling all the time. But they're moving so fast around the Earth that the fall never makes them hit the ground. They miss the ground all the time. The International Space Station isn't getting any closer to the ground as it falls, because its falling is just matching the curvature of the Earth. That's called orbiting. Now, that's not the only case of orbiting. There are cases where orbiting involves falling closer to something, speeding up as it falls closer, missing it, um, and reaching escape velocity as it speeds up, and then moving farther away because it has reached escape velocity. And not only doesn't fall closer, but actually falls farther away. It's still falling toward it, and the falling still curves its movement, which would otherwise be a straight line in space. But you end up with an elliptical orbit. So let's see, if we go back to this and see where that plus sign is at now. Now it reloaded the page, so notice the plus sign is back at the beginning of the red line of the path, which is what shows when the International Space Station is expected to be in daylight. Um, it's now showing that when it makes a full orbit from here, in the last bit of that full orbit, it will be passing directly over New Zealand, as opposed to it came very close to New Zealand earlier, but it didn't pass directly over it. So I wonder. Um, I'm not good with timing such things, but I wonder if I could manage to maybe film it going over New Zealand later. Now, I'm not sure the way the camera is aimed on the International Space Station right now, whether we would see New Zealand or not. They used to aim the camera more at the ground, and they actually were using a camera that distorted the image, what they call what's called barrel distortion, or what some people call a fisheye lens, or also known as a wide angle lens. And the reason is because you could see more that way, because it takes a larger picture of the ground, or a larger picture of what's out in front of the camera. And I don't know how many other people might have suggested this, or whether or not the suggestions made any difference, but I did at one point call up NASA and suggest to them that they switch that camera and put in one that doesn't cause distortion of the image, or that causes as little distortion as possible, so that people could actually see clearly, as I was demonstrating earlier, that the horizon of the Earth actually is curved, that the Earth's surface actually is curved and not flat. And I don't know whether they listened to me or listened to other people, or if they just somebody there independently came up with the idea. But it's cool that um, it was actually done, and that somebody did switch that camera out and put in one that doesn't distort the image. Although I have to say there was something nice about the having the larger view. I actually did during that time manage to identify a few pieces of land as they went underneath the space station, and again, I'm not really sure whether or not I could, whether or not we would see New Zealand under the International Space Station with the camera that we have now when it's passing directly over it. Something, of course, as large as, like, say, North America, if you're passing right over the middle of it, you're not going to miss that. You might not recognize it, though, because you're still, I mean, this is only 254 miles up in the air, so that's still pretty close to the ground, and you're not going to see something like North America as the shape you would expect to see it on the map. And there are no political boundaries marked out either. So if you're used to seeing, for example, the shape of the United States of America, continental U.S., or the shape of Mexico, or the shape of Canada, you're not going to see those with their markings within the continent. You're not going to see the shape of Texas, um, other than the fact that it's got oceans around it, and you can sort of make out part of its shape that way. But it's also bordered by Mexico, and the whole Mexico Texas thing kind of looks like one thing when you're looking at the Earth, and not at a map where they've been clearly marked off for you. So, at any rate, yeah, that's all I really wanted to make this video for. Um, Basically, can you see this map moving? Um, do you see that it is actually moving? Um, you might notice the um, shaded area over here. That's actually um, that's actually the sunset coming up. It's not shown real well to be a sunset on this map. Some people might be expecting some color or something there, but it's a map. This is a simple graphic representation, and as you can see, the east coast of the United States is heading into that sunset area. It's not that the sunset is moving closer to the United States. It's that the United States is moving closer to the sunset. Now, that might be a little bit confusing on this map because if you watch this map is moving toward the left, and the sunset um, will be moving toward the left a little bit faster than North America is moving toward the left. So it kind of looks like the sunset is slowly overtaking North America and South America for that matter. If you go farther down here, so the sunset is slowly overtaking America um, from that perspective. But that is the perspective of um, looking at the map with the International Space Station basically at the horizontal center. So the map is moving to keep up with the International Space Station, which is staying centered on the map horizontally. And you will notice it moves up and down, so they haven't centered it vertically on the map. They could have done that. That's not the way this was done. The globe has been spread out into a rectangle, which actually makes the poles not points but lines on here, literally stretched out across the top and the bottom. So there's a lot of distortion involved. And as a matter of fact, um, well, let's see. Can I move this so that Antarctica shows up? Yeah, there's a little bit of Antarctica showing up here at the bottom of the map, and yeah, I think I had it where it was for the text that's above that. Um, Maybe I should move that somewhat. I'll just leave it like that for now. Any rate, um, but but yeah, the surface of the Earth in reality, in relation to other things in outer space, in relation to um, itself, really, in the relation to the content of the Earth, because it's rotating. It's not just moving in a linear direction. Um, everything everything on Earth is technically falling. Um, well, okay, I shouldn't say everything. Everything around the equator, everything that's not at the poles, is technically, in a sense, falling all the time. Uh, Everything's trying to fall. Everything is, everything's being pulled by gravity. I shouldn't use the word trying, but everything's being pulled downward by gravity toward the center of the Earth. There's stuff in the way. If not for that, if not for everything being pulled toward the center, then yes, things out at the equator and to a lesser degree other stuff on the planet would float off into space. And not only would it float off into space, it would be in a sense flung off into space. Now, when I say flung off, I don't mean flung off um, with some huge angular force away from the planet, because the planet's only rotating at a rate of 1 degree every 4 minutes. But at the equator, that's still around 1,000 miles an hour of linear motion, and it is gravity pulling stuff back down that keeps that from causing things to float up away. Now, it's all moving together at the same speed, so you wouldn't have some stuff flying way out in front of other stuff toward the east. because it's all going east at the same speed, or roughly the same speed. The closer you get to the poles, the slower it's going east. The closer you get to the center, to the core, the slower it's going east. But out at the surface, near the equator, it's moving pretty fast that way. And if gravity wasn't holding it down, stuff at the equator would be flung off at about 1,000 miles an hour, and stuff below the equator, um, south of the equator, north of the equator, or literally underneath the ground that's now on the equator, would be flung off at a slightly slower speed. And basically, the whole planet would fly apart. Gravity literally holds the planet together. Now, I know there are flat earthers out there that say there's no such thing as gravity, but if that were the case, our planet would literally fly apart. And if you run a few searches on YouTube, you can probably find um, videos of astronauts experimenting with water in microgravity environments. Now, I say microgravity rather than zero gravity. A lot of people like to say zero gravity, but wherever there is mass involved, there is not zero gravity. You just can't have that, because all mass, as far as physics knows, has a gravitational field. And so, if you've got two humans in spacesuits out there, uh, without a space station, and um, far from any planet, they still have gravity with relation to each other. And if they were to, say, for example, just slowly shove off from each other and float in opposite directions, um, if they weren't moving apart too fast, eventually they would fall back together. Now, they might miss each other, and if they did, if they fell back toward each other and missed coming together, then they would continue right on past each other and eventually slow down and probably come back for another fall toward each other. If this continued, they would be in orbit around each other. That's what the definition of orbiting is. The Earth orbits the Sun, but to a much lesser degree, the Sun sort of orbits the Earth. Now, I say sort of because the Sun has bigger things pulling on it. But the Earth does affect the Sun to a tiny extent. That the Sun is actually being pulled, and its motion affected by the gravity of the Earth. Earth's gravity is just really, really tiny compared to the Sun. And in the same sense, the Moon orbits the Earth, but the Earth is also orbiting the Moon, or more accurately, they're both orbiting their common center of gravity. If you were to take the Earth and the Moon as a single object, if you were to consider the two of them combined to be a single object, you could say that object is rotating. And in a sense, that would be an accurate way of depicting it. The object would be rotating around its common center of gravity. The distances between them are not completely uh, stable. There is a little bit of back and forth of, um, the distance gets slightly greater and slightly less. This goes back to the elliptical orbit I was talking about earlier. Technically, all two body orbital paths are elliptical. A circle just happens to be a particular type of ellipse. It's an ellipse that has both of its focal points in the same place. For those who know how to make an ellipse, or understand exactly what an ellipse is, that should make sense. And for anybody else, well, it's something to think about. And again, you can probably run some searches and look this stuff up if if I've said something that's over your head or outside of your normal scope of things that interest you. And don't get me wrong, I'm not by any means one of these people who thinks I'm smarter than you because I know things you don't know. Fact is, you know things I don't know. I'm sure of it. Whoever you are, you know things I don't know. That doesn't make you smarter than me either. You might be, but the fact that you know things I don't know doesn't mean you are, and the fact that I know things you don't know doesn't mean I'm smarter than you either. And I don't know which things I know you don't know, so that's why, since there could be anybody watching this, I might from time to time say, well, if you don't know what this is, or if you don't understand this, you could look it up and find some details on it, or I may explain something that many of the people watching this might not feel needed to be explained at all. Now, it looks like, if I'm seeing this right, it looks like the International Space Station is coming up right about at the tip of Texas. Now, I'm not the greatest with geography, so I don't know quite how accurate that is, but I'm pretty sure the tip of Texas is right about here. If I've got my mouse in the right spot, I think that's about right. And then all of this down here is Mexico, and then Central America, and of course we've got South America over here. I'm not sure. Actually, I think the tip of Texas might be closer up here. Having trouble holding my mouth still. Sorry about that. Any rate, so I'm going to switch back over to the ISS live feed and see if we can see that. Here's the Gulf of Mexico here that it's coming up on. Maybe we'll see that in the image. So switching over. This video is already 26 minutes long. I don't plan on cutting it. I do plan on trimming the frame a little bit, but I'll try to leave in the important stuff, the image we're looking at, and the address bar. In fact, really the only thing I probably will be cropping out is way over on the right hand side. There's a little thing that says live, and I'll probably crop that off, since that way it doesn't give any illusion that my recorded screen capture is live. And also the tabs at the top of my browser window, since they're just sitting there static anyway, and they're not really adding anything useful. So yeah, looking back at this map, we can see, looking by the line here, this direction that the International Space Station is moving in is toward the northeast. And going back on the map here, we can recognize then which way is northeast by which way the planet is rotating. Oh, look, there's that piece of land here, and there's the Gulf of Mexico. What is that piece of land called? Yeah, I should know that. Any rate, there's that little piece of water in between here and mainland Mexico. I believe that piece of land is actually part of Mexico. I should know that for sure. As I said, geography is not really one of my strong points. This goes back to what I was saying earlier about, I know things, you know things. And so, yeah, this is what Mexico looks like. Mexico and maybe part of Texas from this particular angle. And hopefully anybody who's stuck with me this long can see what I was talking about earlier about it not being real easy to recognize such features when we're that close up. I mean, look at the size of that big piece of land that we just went over there, and compare that with back here on the schematic diagram type map, that little tiny sliver that you can barely even see is there at all. And yeah, it looks like we're running right up along the division between Mexico and Texas, more or less. And it's really hard to see what's down there because there's a lot of clouds over it right now. You can still see parts of the ocean way down there uh, near the horizon. Now, of course, if I were to edit this, I'm not even sure if I would have a way to do this, but if I were to edit this and flip the image upside down, or maybe rotate it 90 degrees clockwise, that would probably look a lot more familiar to most people as far as um, having the ground below as opposed to the ground above. But this is the reality of life in outer space. The International Space Station has people working on it at any given time, and that's the reality they deal with. When they look out the window, the Earth isn't down in any really subjective, any really objective sense. It's a matter of it's down if you call that down. Because as I said earlier, technically they're falling toward it, um, but never really getting any closer to the surface, or not any substantial amount closer to the surface. They might get a little bit closer, and then on the next lap, they might get a little bit farther away. I'm talking what, centimeters, maybe. Yeah, occasionally, such an orbit has to be adjusted a little bit, but for the most part, it's pretty steady, pretty stable, and there is a little atmosphere up there, by the way, 254 miles away from the planet. You couldn't breathe it. It's not thick enough. As a matter of fact, it gets difficult to breathe the thin atmosphere near the tops of some very tall mountains. And as you can probably tell, looking up at the ground, uh, the mountains are really, really, really small in comparison to the distance between the ground and the International Space Station. There isn't much atmosphere left up there, but the little bit that there is does cause a small amount of drag, and does affect the uh, orbit somewhat over an extended period of time. And occasionally, as I said, occasionally they do have to make some small adjustments as a result of that. So, any rate, I think this is a long enough video. It's over a half hour already. Far more than what I had intended. I really only had intended to just briefly um, have a look at this map and show that, as a matter of fact, the map is moving toward the left, and um, doesn't really, at first glance, appear to be. And in the same sense, um, the Earth is not spinning as so many flat earthers want to say that people who understand the Earth as globe shaped or spheroidal. They want to say that we're claiming the Earth is spinning. Well, yeah, some people do occasionally misuse that word, but in any other context, the word spin means to rapidly rotate. And as you can see, looking at um, the speed this line between day and night moves, it's not rotating rapidly. It's rotating, but barely. As a matter of fact, in all the distance that this map has moved to the left, you might notice we started out with New Zealand near the center, and and hardly any of North America or South America in the shadow, um, in the nighttime. In all that time, this shadow line, this sunset line, has barely moved. and New Zealand is way over there on the left now. Um, Australia is practically getting ready to go off the map and come back on the other side, and that is another thing that should be a bit of a clue for people who think that that the Earth is square. There are people who actually think the Earth is flat and square, with the Pacific Ocean, with half of the Pacific Ocean being on one side and half of the Pacific Ocean being on the other side. As you can see, the Pacific Ocean is actually one ocean. There it is. And yeah, in a while, this map would be far enough over to the left that it would match that particular flat Earth map. But again, not without extreme distortions. And the more commonly accepted flat earther map that has a North Pole but no South Pole doesn't distort the northern hemisphere real badly. It does distort it, but not real badly. It distorts the southern hemisphere terribly. Most notable by the fact that Antarctica, which is showing here as this stretched out continent across the bottom, which you can only see pieces of because they've actually not not shown all of Antarctica on this map. Um, it ends up being a circle around the round flat Earth, around the circle shaped or disc Earth. And let's see if I'm going to open one more thing here. For those who don't know what this is, epic.gsfc.nasa.gov. This is an actual photograph of the Earth. And now I've got my window size a little too small to see the whole thing. You can see in the lower left corner, and I'll try to make sure I crop it so that stays in there. In the lower left corner, you can see a schematic representation. Over here, you can see there's Australia, and then if you look on the actual photograph in that same area, there's Australia. And if you scroll farther down the screen, you can see there's some information on the image, and also here's a calendar that you can click on and scroll down a little farther, and you can see December 1st and December 2nd are the last 2 days that it got images. We're on December 4th. So today and yesterday, this camera didn't manage to get any images back to Earth. Apparently, now I'm guessing they still collected some data, but that it was too badly corrupted due to atmospheric conditions and whatever else gets in the way to be able to actually make a good, trustworthy image out of it. So they didn't add it to the online collection. And if I click this, you can see I'm moving through the images, and you can see Australia moving over here toward the right. That's actually the direction that the Earth rotates in. And there's Africa, again moving toward the right. And all I'm doing is I'm going through different images that were taken on that same day, on the 2nd. There's South America on the left, and again, if you look on the schematic representation, it's easier to make out. And if I keep going through the images, it moves farther to the right and farther to the right. And that right-hand edge, of course, is the east coast. So what's happening is as that moves toward the right, it's getting closer and closer to the night side. Right now, this is all on the daylit side. It's taken by the Discover satellite, DSCOVR. The camera is actually called EPIC, EPIC. It's an acronym, and I forget off the top of my head what it's an acronym for. Both of those are acronyms. And the satellite is out in Lagrange Point 1, roughly 1,000,000 miles away from Earth, which is why it sees so much of the Earth, as opposed to the International Space Station, is so close up that the horizon makes up a very small area. So instead of seeing from here to here with the International Space Station, you might be seeing them maybe from here to here. It's a little circle within this, and if you can remember the well, let's see. Oh, it doesn't quite show up on the screen here. Here, wait a minute. If I bring this down, well, there is Mexico, and that little piece of land over here. Remember how much bigger that was looking from the International Space Station. That's much more zoomed in, and of course, you're not seeing the whole disk from the International Space Station live stream. In order to show the whole disk area, the whole visible area. Oh, we just went into sunset. Yeah, the sudden change in the picture, by the way, that's only because I had navigated away, and when I come back, it picks up where it left off, and then catches up quickly. But yeah, if we go back to this map that shows where the International Space Station is at, we should be in the dark side. And there we are. We are in the dark side. And you can see we've just reached the blue area of that line. And that's where the space station is in the dark. Now, it's not in the dark yet, but you can see it's getting there. And so as long as I've had this going this long, I'm gonna keep it going a little bit longer and let it finish this sunset. Now the changes in brightness, getting brighter and dimmer and brighter and dimmer, that's the camera trying to adjust for the actual changes in ambient brightness. There you can see it's doing a pretty good job there of keeping some of the space station visible with very little light left. But that light will eventually go away as well, and we'll be left with nothing recognizable. Over here on the right side of the screen, I usually try to crop so that this isn't so obvious, but over here on the right side of the screen, you can see sort of a reddish area, and then it switches to black. There's like a really dark red, and then it switches to black. The black is where it's actually outside of the camera, and the reddish area is the camera trying to basically jack up what little bit of light it has, enough to make an image for you. And the human eye does that too. Doesn't do it in exactly the same way, but human eyes, the human visual system, does also try to compensate. And obviously, because of the changing conditions, they've got this camera set to do that automatically. This tiny little bit of blue here that's left here, that's the horizon of the Earth, which would extend up roughly this way. And what did I just do? I think I accidentally caused this thing to... Oh, sorry about that. Not sure what I did. Well, maybe it wasn't something I did. Any rate, here, let me try refreshing it. And scrolling back up. So yeah, I'm not sure exactly what I did. I don't think I hadn't clicked on anything on purpose, but I'm using a touchpad, and sometimes it's a little sensitive and it'll think I clicked when I didn't. So there, I've got the image back, and as you can see now, the horizon is no longer lit. And although there is a faint glow all over this thing, it's, I would say, pretty much impossible to make out any details of anything within that faint glow. So yeah, this edge between the dark red and the black, that's not the edge of the Earth, if anybody might think it was. That's just the edge of the camera's sensors. And that's it. I'm going to go ahead and stop the video. Let's see, where is... Here. Stop the video. Thanks for watching.